All right, perpendicular bisector. Give me some characteristics of perpendicular. Okay, yesterday, we did some notes on this. Okay, so. What did the word perpendicular mean? I said there was 2 characteristics, and y'all broke them down into 3 because you kind of broke one of them apart a little differently. What are perpendicular lines going to do? Anything perpendicular, what's going to happen? You have 3 characteristics that we defined yesterday. I want to see if we can remember them. What you got over there? Crossover. Crossover, is that a word we've been using? Intersect. There we go. We want to try to use the precise mathematical language, so therefore we know what we're talking about. It's doing that. Totally agree with you. Okay? But these are going to intersect. What are the lines that don't intersect? What is the line that does not intersect? Parallel. You're good. So, all right. Next, what's another characteristic of perpendicular? Not all of you at once. Calm down. Okay, quit rushing the screen. Another concept. Yes, sir. What do you mean?
Like the angle.
The angles. Okay, so now let's talk about the angles, and I would agree they are congruent. However, we know exactly what their value is, right? What are they?
90 degrees.
Good. So we're going to have 90-degree angles. Okay, 90-degree angles. And what do we know about all those angles? The angles are congruent. What do we call 90-degree angles?
Right angle.
Good. All right. All right, now, we'll move a little further. Bisector. What does that word mean?
2 equal parts.
Okay, you jumped in there, right? So, 2 sections is what we said yesterday, but what do we know about those sections? When I cut something into 2 sections, I can do that a lot of places. But what do we know about the 2 sections that are created? They're equal, and we call that congruent. So it's 2 congruent sections. So what do you think is going to happen when I put those 2 things together to get a perpendicular bisector? Can we put all that together now? And all those bullets come together. So if all those bullet points come together, perpendicular says I'm going to have a line that intersects it, that creates 90-degree angles. And how many of them? How many 90-degree angles are going to be created with those 2 intersecting lines? Huh? 4. And all those angles are going to be congruent. And then what happens to the line segment? What happens to the line segment that they're intersecting? Broken into 2 congruent pieces. All right, so I want you to be able to put that together because knowing your terms and defining your terms is important. Okay? You don't have to say it exactly like me, but there's some mathematical language that needs to be in there. Like you could say right instead of 90. You are getting in each other's way. I'm just telling you. So we got to be able to use some of that because there's a piece in here that you just defined for me that I guarantee you is what you're going to mess up on in this construction. All right? So it says, after coming up with a method, copy this segment, which we did on trace paper, and you check it out. Did anybody check that out? Did theirs work out? Raise your hand if yours worked out whenever you checked it on trace paper. Thumbs up or something. None of y'all's worked out? None of y'all's worked out when you checked it, or you didn't check it? No answers. All right. So, here's the thing. Somebody tell me what they did to draw this perpendicular bisector. What are you showing me?
I just drew a line.
You drew a line. Is that good?
No.
Well, I mean, just drew a line. I'll follow your directions.
I think the middle line in the middle.
Oh, now we're getting a little bit better. So how did you find the middle? You guessed. We have a guess. Is that okay? All right. So, that looks like the middle, right there. That sound good to y'all? What do I do next? Draw a line through it. May I borrow? Oh, got a vertical line. May I borrow your straight edge, please? Okay. That's fine. I said straight edge. I didn't say ruler. I'm good, right? All right. So how do I know that that's right? I check it. How do I check it? Huh? Check it for 90 degrees. So now you're talking about a tool that I don't have listed yet. What tool are you going to use to check the 90-degree part? What is that called? Anybody? 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 Protractor. I can use a protractor to measure the angle. So if it's 90, it's perpendicular, but it has two pieces to that. The other piece is, what does it have to do to the segment? The other piece? Perpendicular's fine. What's the other piece of the word? Bisector. Does it do that? How do I check that? How do I check to see if where I put my point is correct? Am I speaking a different language?
No, we just don't know the answer.
You don't know how to check? Okay, what you got? I'd rather y'all say that than just stare at me.
Measure it with a ruler.
Measure it with the ruler. Awesome. So I'm going to do so, okay? Does it matter what units I use? It doesn't, does it? It may not come out to be pretty, but I bet none of you in here need to use inches yet. So, I'm going to measure it with a ruler. I get a dimension. Oh, crap. Comes out to 4 point something. Dang it. That's not fun to divide. So do you think that there might be another way that I could do this? Because two errors could happen here. One, you said I'm going to guess where the middle is and put a point. Then I'm going to draw a vertical line and I'm going to call it a good day. That ain't going to cut it. Here's the reason why. A line, one of y'all come up here. Don't throw your hands in the air. I hate that more than anything. I hate it when you go. What you trying to do, a magic trick? We got too much distraction going on back there, and you're going to get out of each other's way or I'll call you out. And I don't care if you're on video. Now, and so on here, the problem you have is the definition of a line. Because a line requires what? To define direction. Define direction. And, as you called it, verticalness. What do I need? Can I just draw it because it looks good, or do I need something else that I can define it with? A line in geometry is defined by 2 points. 2 points. You used 1. So if I go back to my picture, how many lines can I draw through that point? Huh? Many as I want, right? I can go that one, I can go that one, that one, that one, that one, all the way around, right? You said draw vertical because you understand that it needs to be straight up and down. Because straight up and down and straight horizontal creates 90. There's nothing wrong with that understanding. It's how to make it perfect. How do I make it perfect? And I need another point. So I'm going to leave that line on there. And you know what? I guessed the middle pretty good, looks like. And I'm pretty good at drawing a straight up and down line. But I'm going to see if it's accurate. All right? Anybody else do anything differently before I start going through this? What do we got? Go ahead. One of you speak.
So I drew a circle centered at Q and had a radius of P, and then drew...
Okay, we're going to stop right there and do that one. So he drew a circle that has the radius length of PQ, putting the point at P. Does that instruction sound pretty common to what we've seen all the way up until this point? Constructing a circle tells you got to have a defined radius. I have a line segment that represents the radius, and so therefore I'm going to put my point here. I want to put my pencil there, and you're going to draw a circle, correct? that what you said?
Yep.
Yes. All right. I'm not going to draw all of it because I don't have to. But you could draw the whole circle, no problem. All right. So that tells me that Q is the center, P is the radius. What do I do now? Yes? Same thing on the other side. So here's what I'd like for you to do. Before I do it, if circles were not used by you, I'd like for you to... How many of you don't understand what that move is doing right now? We're just drawing two circles using the radius length of PQ. So if you didn't do that, and you're not lazy, I want you to do it on your paper. Perform that. I'll give you a second to do so. Don't want you to be lazy, though. I want you to do it and try it. Hey, do you need this? We're using that one. I think you get it, but he's not going to pay attention. Okay? I'm trying to help him out. Now you can go ahead and do both circles now. See what you think happens. What do you notice that happens when you do two circles? Huh? They intersect, right? They overlap. What did we say we could create when things intersect? Don't try to be too scientific. Don't try to be too geometric. What happens when two things intersect? What geometric thing is created? Huh? Huh? A point. We have a point. We'll just talk about those points in just a second. Don't try to be too smart yet. And so I'm going to perform the other side. It shouldn't have changed. And I have two intersections now, correct? So at intersections, I could do that point and that point. What do you notice about my point and the line that I drew? It's a little off. So you know what that means? What I guessed was not the middle. So at any point, guessing doesn't help me there, right? There's got to be something that I can clearly define. And so what really happened... Let me borrow your straight edge again. I'll look at you now. You give me... What really happened is I found the exact middle. I found the exact middle now. And what do I know created right here in the middle? Is that a vertical line? I don't have to try to draw a vertical line. I know for a 100% fact it is. What happens when I have a vertical and a horizontal line intersecting? Yeah. I have a right angle right there represented by that box. Right angle right there represented by that box. There, there, and my point moved over to right there. So when I have that point defined, what do I know about this distance and that distance? What do I know about those distances? They're the same. And we call that when something's the same, they are congruent. And here's how you symbolize that. Put a tick mark there and a tick mark there. All right? Now, I'm going to show you some terminology or the way to notate it. I'm going to call this point that I created in the middle, let's call that point R. So if I was talking about those segments, I would say segment PR is congruent to segment RQ. Yeah? Do we agree with all that? Do we understand why mine didn't work and now why it did when I used the circles? What about the circles made those congruent and made those intersect. Yes, sir.
You made the circles both equal sized.
Okay. Can anybody build on what he said, equal sized? Go ahead.
Oh, well, like when they intersected, it was like it just lined up the middle of each intersection. You just put dots and then.
So my question is the equal sized, because I like that, but I want to make sure everybody understands. What did I do to make the circles equal sized, as we've quoted it? Very good. I use the same radius. Can I have circles with the same radius that aren't the same? I can't. If I use that radius, they're going to be equal. They don't have to be in the same spot, but they're going to be equal in size because I use the same radius. Yeah? Okay? Good.